Welcome to Programming Rainbow. In this video, we will continue on the series of Conway's Game of Life written in C and SDL2. So if you want to follow along with this video, you can go to github.com, Programming Rainbow, Conway's Game of Life, C, SDL2. You can clone that repository, move inside the directory. And since this is the second video, you'll want to delete the source directory and copy the video 1, which was last video, and rename it source directory. So you will be working with the source code that we just finished off with in the last video. So let's look at this code. So I'm just going to show you the finished project real quick. And we don't need to clean, we can just run it. I'm going to show you the final project. So this is Conway's Game of Life. There is rules to how each one of these is alive or not alive. If I were to add a square right here, we'll see that this shape changes right there. And we can do it here as well. And you can look up what Conway's Game of Life is. There's all kinds of things, but this is just a simulator for it. And I can speed up the speed and I can slow it down and I can pause it. I can clear it. I can put random ones in there. So I could speed it up. I could clear it, random ones, random, every time I hit random, it's going to do it. And you can also edit it by clicking on them. You could draw shapes at the things, like I could put one here and see what that does. It's pretty interesting. That's just showing off the thing. I'm going to show you what we ended off with in the last video. So by default, make will just compile what's in SRC. I told it instead to compile video 6 so you can see the final project. I'm going to do a make clean and then run. So this will clean the project and then rebuild it and run it based on the source directory. So the last video, we got this. After 5 seconds, it closes. We can't close it ourselves. So in this video, we're going to be doing 2 things, or 3 kind of. We are going to create our game loop. So instead of it just sitting there for 5 seconds, it's going to run at about 60 frames a second. We will also be controlling the shutdown. So we'll be checking events and seeing if quit event was requested or if an escape key was pressed. So we have our game loop and we have our events being checked. We are also going to set the window icon for this. And to do that, we need to bring another module online so that we can load images. So we're going to be bringing a module online to load images, and then we're going to be setting the window icon with an image that we load. So all those things are kind of little mini things. They shouldn't take too long. So let's get started. So again, this is the second video. If you're just starting out with this one, if you just clone the repository, you want to grab the source code from video 1 here, because what's in SRC is the final code, which is from video 6. You'll want to delete this directory, copy this, rename it to SRC so you're where we are right now. So what we ended off with is just this run right here, and it is just clearing it and presenting it. If we were to create a game loop right now that just run in a continuous loop instead of this 5 seconds, we would have the problem that our game would never be able to shut down because we're not checking events. So let's talk about events first. We're going to be using this pull event to kind of get us each event in a queue. So let's first talk about what an event is. An event in C is a union, not a struct. So it can hold many different structs, but it's only going to hold one at a time. So it is going to be an event, and we're going to pass in the address of an event to populate it here. But let's find out what an event is first. This event is basically a union that can be any one of these things. So the first thing that we have to do before we process it any further is find out which one of these items it is by checking the type. So we can check the type, and the very first thing that we actually want to know is, was a quit event requested? And we can actually just get that from the type. So if we go down, these are the types that it can be. And one of them is just SDL quit. So if we were to close, like the X or whatever it is for your operating system, that is going to trigger this. The event that goes onto the queue, one of those events is going to be of type SDL quit. And we don't need to process that any further. We don't need to check any deeper. We know that something has requested this window be closed, and we can shut our program down. So that's the simplest thing that we can do. So let's just do that first. So just know that this event is a union. Before we do anything further, we need to check the type. but one of the types is just an SDL quit. So just getting that type is enough information for us. We don't need to look at anything else. We don't need to check what kind of quit event it was. It's not really important. We just know that one of the events is a quit event. So I'm just going to go through what this means real quick. Back to this SDL pull event. What happens is in our game, if we had a loop here, let's assume that this is a loop, that this is running over and over again in a circle. Say we're in this pausing, right? And I move the mouse. That's a whole bunch of events. That is like an event for the mouse to move and where it moved to. I could click the key as well. I could hit J at the time. Something else could have happened. Those are all events. So what we need to do is we're going to have this queue of events that SDL has for us, and we need to go through them one by one and say, what is this event? What is this event? What? And we're going to check the type first. So we could have like 50 different events that are on the queue waiting for us to look through. And all we care about is one of the types an SDL quit. So we're just going to run through all those events in a while loop. And whenever there is an event, we're going to just check, is this a quit event? And we're just going to keep going until if one of them is a quit event, then we're going to shut down our program. So that's kind of what we're doing here. SDL pull event is a function that is we're going to pass in the address of an event. So it's going to populate it for us. And it's also going to return if this was an event or not, basically. So if it was events, it's going to return 1. So when we call this function, we need to pass in the address of an event so it can populate it for us. And it's going to return 1 if there was an event. So now we know we can process this event. But if there wasn't an event, if we pass it in and there was an event, it's going to return 0. So we can use this in a while loop. We can call this function in a while loop, and it's going to just keep populating this event over and over for us until that this is 0, and then we don't need to look at that event because it wasn't populated. So right here, so this is assuming the game loop. This is like a sentinel value on the game loop. Right here, they're declaring an event right here. And now we're sending in the address of that event into this SDL pull event function. And this is in a while loop. So we can see what's happening here. This function is going to get called. We're passing in the address of this event. It's going to be populated for us. If it is good, this while loop is running. The second it's not good, whenever it returns a 0, this while loop is done. So this is going to allow us to go through all events in our event queue one by one, get an event one by one, and then we can process it. And what we're going to be doing is checking to see if it's an SDL quit event, if the type of the event is SDL quit. Now, I'm not going to declare this event like they're doing. So they're declaring this event over and over inside the game loop, and you don't need to do that, so I'm not going to do that. I'm going to put it into the game struct, and I'm going to have it live there, because why do I need to keep creating it over and over again? There's no reason to do that. And that sentinel that they were showing here, we're going to create one too. Game is still running. I'm just going to say is running. I'm just going to make a bool called is running. And I'm also going to make this event, which is just of type SDL event. And it's not a pointer or anything. We don't need a pointer. We just need the actual event. Passing it into this function is where we need the address of it so it can actually deal with that, because it's C, and that's the way it works when you pass in something into a function that you want to change. So I'm going to go into game H first, and I need 2 things here. One is the SDL event. We can just call it event. Right there. And the other one is this kind of sentinel bool. So our game loop, we can make it close. So we can run our game loop as a while loop, and we can just change this as true or false so that we can stop our game loop from running. I'm just going to call it is running. Okay, and that should be enough for that. So I'm going to put 2 functions up here. The reason why I'm not putting them in the header file is because nothing else needs access to these. So the ones in the header file main is having access to those, the game new, the game free, and the game run. But I'm going to add 2 more functions that are only being used internally by game. So they don't need the visibility outside. So they're not going to be in the header file. They're just going to be up here. And it's going to be game events. This is the processing of events. I'm going to do it in its own function. And I'm going to take the drawing of the game and break it out into its own function as well. Later on, we'll have a game update too. But right now, it's just going to be game events and game draw. Okay. In my notes, I have this as a bool. Later on, it will be a bool. But in this video, it doesn't need to be. So I'm going to just make it void. So game events, nothing's going to be failing yet. Later on, it'll be calling functions that could fail, but not in this video. And this is just the same thing every time. It's going to be game. It's going to be G as a pointer to a game struct. And that's pretty much how every game function is going to look. Sorry, I'm not defining it here. I'm just declaring it. And we also need the game draw. And same thing, G is a pointer to game struct. Okay, so these are just forward declared. So my compiler doesn't complain about it, and I'm going to put them here. So the first thing we want to do is deal with these events. So I'm going to create this while loop right here, this inner one. This is what I'm creating right now, where I'm going through. Remember, we have a queue of events. This pull event is going to grab one of those events off the top of the queue, and it's going to keep doing it until it runs the queue out. So there's a queue of events, and we just keep passing in the address of this event, and it keeps populating it until that queue is run out. So that's what I'm putting inside of this game events function. And this one is pull event. And now we need the address. Sorry. I was going to write this event. Okay. So the event was already in the game struct. Okay. So this is just us passing the address of this game event. Now we can process it. And what I'm going to use is a switch statement. And I'm going to switch on the game event type. So let's go back here real quick. These game events always have a type. So when you're dealing with unions, you're going to check the type first. So it's going to be game.type is what I'm interested in. That's what I'm going to be switching on. So this event's been populated now, right? So it's going to be event.type. And the case that we're looking for is down here is the SDL quit. That's one of the types. So this is all the different types you can have, and it's telling you which one of these structs it's going to be. But I don't even need to look inside the quit struct, because if a game quit event is triggered, that's good enough. That tells me I need to shut down. So SDL quit. This is all capitalized. And what we're going to do is we're going to change this bool that we had. Remember that we have this boolean that is running. We're going to change it to false. And I haven't set it to true yet. We need to do that, but I'll get to that. So this is G is running is false, and then break. And we need to set a default as well, or the compiler, depending on which settings, and I use quite strict ones, will complain about this. Okay, so the issue we're having right now is we're not doing anything with this yet. And also we haven't even set it to true yet. It should be true by default. So I'm going to set it to true up in this, the game new, right up here. And we could set it to true right away. Yeah, I'm just going to set it to true right away, because it's just a simple thing. We're not really processing anything. Okay, so that's going to be set to true when we have the new game. And now if we ever if we ever pull events and any of those events is an event of type SDL quit, we're going to set that true to false, and that's it. So this is just a simple switch statement with just one case in it right now and a default one. And all it does is change that Boolean. So now we can kind of make a game loop. Although before we do that real quick, I'm going to pull out the drawing stuff into the draw function. So it's just going to be a simple copy paste thing. And it's the same. G is a pointer to game struct. Okay, and what I'm just going to do is I'm just going to take these two right here and I'll put them in here. Okay, so now we have our vents, we have our draw. Now we can turn this run game into a game loop. And we don't have to worry about it running forever. So we can just do a while on the sentinel value, which is running. While is running. And we want to check the events. And this is returning void right now, so we don't need to do anything else with that. We can just do that directly. And then we also need to draw. We need to pass G into that. Okay, so it's going to call this guy up here. So we're just passing, G is already a pointer to game struct, so we're just passing G in. And we're doing that. And then after that, we're doing it here. Again, G is already right here, so we're just passing it in there. And now we have to talk about this SDL delay. This is a 5-second delay. We don't want our game loop to be 5 seconds. That's way too long. So I'm going to approximate 60 FPS. Later on, we're going to change this. But right now, I'm just going to approximate 60 FPS, which is about 16.6666. However, SDL delay function only takes in a unsigned 32-bit integer, which is not a float. So I'm just going to put 16. It's going to be close enough. It's going to be between 60 and 62, depending on how fast your computer is and how much time the logic of this program takes. Probably going to be about 62, but it's not really important. So I'm going to take this right here and I'm going to put it inside the game loop. But I'm going to change this 5,000 to 16, sorry. So that's 16 milliseconds. So if you were to take 1,000 milliseconds, which is 1 second, and you were to divide it by 60, you'd get 16.6666. But and this is just a pause delay time, but it also takes a little bit of time to run the logic, of this processing events and drawing. But really, it's probably not even a millisecond because this is it's not really doing anything. And this is void still. Nothing. Later on, this is going to be changed. These voids are going to be changed to bools, but I'm not getting a return right here. Nothing's erroring, so it doesn't matter. Right here, I'm not checking anything for erroring, so it doesn't matter. So in here, it doesn't matter right now. So we should be able to close our window now. It should stay open indefinitely, but close when we tell it to close. Okay, so here is our window, and I'm going to hit the X, and it's closed. Okay, I also want to set it up so when I hit escape, it closes too. So we do need to process these events a little bit more to do that. So we have these types, right? We check the type to see if it was SDL quit, but another thing we can do is check to see if it's an SDL key down or a key up. Okay, so this is a key event. Now, when we check that, we find out that our event is in fact a key down event. When we check that fact, we need to find out, so what key was it, so we need to process it further. So on this one, we didn't need to process it, but this one we do. If it is of type key down, it's going to be this type of struct, this SDL keyboard event struct, right? So if we looked at this SDL keyboard event struct, one of the members is a key sim. And this is going to kind of tell us which key it is. Unfortunately, this is not going to directly. So I just literally copied this guy right here and pasted it up here to open this next window. So the SDL key sim member has another member called scan code. Now this is what we're actually looking for, the scan code. Okay. So again, if you just copy this scan code right here and you were to put it like up here, you would get this right here, which is the scan codes. These are all the SDL scan codes. So we can check which scan code it was. And so one of these is escape right here, SDL scan code escape, and we can just use that. So what we're going to do is we are going to switch on the type to find it's a key down. But then if it is a key down, we're going to do another switch statement, and we're going to drill all the way down to the scan code, and we're going to switch on the scan code. So then we can easily add in any other key presses we want later on. It'll be easy. So I just want you to kind of see this drilled down. So we're going to do that. So up here in events, I'm going to add another case. Oops. And this one is SDL key down, all capitalized. Okay, so if this key down event is the key event, I'm going to put a break here or it's going to complain. And what I'm going to do is I'm going to put another switch statement inside of this. And the switch statement is not type this time. It's going to be event.key.keysim.scanCode. So it's going to be event.key. Here's the key right here. Because we've already checked the type member of event. We know it's of this type. So it's going to be event.key. And then inside of event.key, it's going to be, I've moved these around. It's going to be this member right here, which is keysim. And inside of keysim, it's going to be this member right here, scan code. I know I moved these around accidentally. I'm not sure what I did. But yeah, that's the drill down of it. Basically, inside of this struct is going to be called key. Inside of this struct, there is another struct called keysim. And inside of that struct called keysim, there is scan code. So it's going to look like this. This is going to be G event, then .key sim, and then .scan code. Okay. Okay. We haven't got the default on it yet. Okay, so we are looking for the case of the escape key. So this is going to be SDL scan code escape. So if the escape key was pressed, what do we want to do? We want to change the is running bool to false, just like we did up here. And we want to do a break. And the reason why I was complaining earlier is we need a default on this as well. For any other key that has been, it needs to be a colon. For any other key that has been pressed other than escape, it's going to complain we're not dealing with all those, and we're just going to put a break. Okay. And again, if you don't put this break here, depending on how strict you make your compiler rules, it may or may not complain. So we should be having this, it should be shutting down now if we press the escape key. And this to add any other key is very trivial now because we can just add another case just like this. And you can put A here or up or down or space, and you could just whatever other logic you want. You don't need to do all this again. This is set up for all key downs now are handled. Okay, so let's see if this escape works. I don't need to do a clean run. I'm just going to do a run. And I'm going to press escape now. And it looks like it works. Let's try it again. And escape now. Yeah, that works. Okay, so that's dealing with events, at least closing events. That's kind of this is the boilerplate. adding anything onto this is pretty easy to do. Basically, this is checking the types, this is checking key downs. If you're doing like mouse events or something, it's very similar, but we will be doing it later on in this series, but not in this video. So that is enough for this video for that. What we want to do now is set the, let me open it again. So right now, this icon right here is this generic X11 icon because I'm recording this in X11. And down here again, it's this generic icon. We can set an icon. And I already have an icon that kind of looks like one of the gliders in Conway's Game of Life. So we're going to set it to that. And that's in an image over here. It's just the icon. That's the only image that I'm using. It's just to load it on icon. So I'm going to get rid of some of this stuff right here. The scan codes, keyboard event, key sim, key scan. Okay. So we want to use the image. We want to load an image. In order to do that, the only way SDL natively can load images is loading bitmaps. And I don't want to load a bitmap. I want to load a PNG image. So we need the image kind of module or whatever it's called, the SDL image. We need this. And to bring it online, it's image init. And there's some flags, and it's basically flags of what type of image. And I'm going to be using, and you can OR these together as well, like I explained in the first video. And I want to use this image init PNG image. Okay. And I'm going to put this into my own flags so that I can OR them out later. And you're going to see why I want to do this in a second here, because it's the way that we check this for errors. What's going to happen here is I'm going to put a flag in here. It could be one or multiple of these or together. I put my flags in here, and it's going to give me an answer back, which could just be the exact value of the flags I put in, but it could be more than the value or less. So I don't know what it's going to be. And so we have to process it a little bit differently. So what we're going to do is we're going to put our flags in. It's going to spit flags out, or some int that is representing the flags. And we're going to use a bitwise AND with our original flags to mask out the answer that we want, to ignore any other information that is not information we want. We're going to use a bitwise AND. And then we're going to check it against the flags one more time to see if that answer to that is the actual original flags that we wanted, to see if this worked. So we need to use these flags 3 times. So this is why I'm going to break them out into my own image flags. I'm just using PNG. That's the only thing I'm using. So I'm going to go into main H, and right here, I'm going to create a new one that's going to be called image flags. And this one is going to be image init PNG. And again, we could put multiple ones here. I could put another like JPEG or whatever, and I'd probably need to put them in parentheses if I did that. But anyway, I only want the one for now, so that's good enough for me. But it is important that I've put it into here because it is going to be a lot easier. So I'm going to go into init, initialization of SDL, and this is where I'm going to initialize this. Oh, one more thing in main H is I need to bring this, I need to get access to this. So we need to add the include. This is going to be SDL2 on my system again, and this is going to be SDL underscore image.h. And that's going to give us access to image. Now it won't complain. So the function is image init, and we have our flags, and it's going to return something out, okay? So this is the idea. Say I want, say my int is represented bitwise by like this. Let's just say this is the flags for PNG, yeah? This is what I want. So I send this into the function, and when I get back is like something like this. Well, these two are not equal, right? But this is information I don't care about. Okay. So this is what I wanted to happen. This is what returned from the function. Now, if I take my original, what I wanted, this one, and I do this one right here, this bitwise and on it, what's it going to do is this is going to act as a mask. This is going to say anything that's a 1, pass that information through. Anything that's a 0, that's going nowhere. So the answer to this being ANDed with this is going to be 0, 0, 0, 1, 1, 1. Yeah? Because it didn't let the 1 go through. That's a mask. Okay? So now this is the answer of my mask. Now I can compare this to what I originally wanted, which is, I could say, is it equal to, 0, 0, 0, 1, 1, 1, right? So this is going into the function. Something's coming back that I'm ANDing with this. And then I'm comparing it to this. So I need them at least 3 times. This one, and this one. Let's assume that what the answer I get back is this. I put this into the function. I got this back. My mask is still this, the same as the original one. My answer from the mask is this. Okay, because I'm masking this out. It's saying 1's through, 0 is through. And then I compare it to this, it's failed. It did not give me the answer back I wanted. So anything that's outside of what I wanted, I don't care about. It could have turned other things on that I'm not interested in, I don't care about. But I do care about what I asked it to turn on. So this is what's going on. I hope my explanation makes sense. It's a bitwise and it's just a mask. So what I'm going to do here is I'm going to say if, and I have the function, which is image init. And I'm putting my flags in. And again, imagine if I was writing these flags manually and I had, and I was ORing them together, I'd have to do that every step of the way and it would be really annoying. And then if I ever wanted to change them, I'd have to change all of them. So I can just say image flags now, which is much cleaner. So remember, this is returning something. Okay. Now I don't actually need to capture what it returns directly, but I do need to mask what it returns. Okay. So I'm going to mask it. So I'm going to use this. So remember, this is returning something. I don't know what it's returning. So I'm going to use my original flags as my mask again. So now I've masked out an answer. So the question is this masked answer what I actually wanted? So now I'm going to check it to see if it's not equal to what I wanted, which is the same again, flags. Okay. So that we got it 3 times here. So if it's not equal, something has gone bad and we have the error, right? So I'm going to copy this right here, put it here as our error matches. And I'm going to say error initializing SDL image. Okay. Now here's the thing. Each of these modules has its own name for the error thing. So it has a name called image get error. But I believe under the hood, this image get error is actually just this function. So you don't have to do this. It'll work either way, I believe. But I'm going to use the image get error. And the return false is still the same. So we're bringing the module online. Let me put this in parentheses. Okay, we need the parentheses there because we need this to happen first, then this, and then the answer to this is being checked against this, and that is the true or false answer. So we've brought image online. The way we bring it offline is the exact same as the SDL one. It's just image quit. So we're going to put that in game free, and it's last in, first out. So of these modules being brought online, the last thing I brought online was the image. The first thing I'm going to take offline is the image. So that should bring the image online and take it offline. Let's just run it real quick and see if we don't get an error. We're not going to visually see anything different, but I just want to see that I'm not getting an error. It's fine. When we load the image, we can actually force an error there that we'll see something. So the next thing that we want to do is load an image. So we've brought the image online. We've used quit, which is just, what it says on the tin. So now we want to load an image. Normally I would use image load texture, I believe it is the name. But in this specific instance, I don't want a texture. I actually want a surface because I'm sending it into the window with this function here, right over here. I'm setting it in. I need it for this function right here, which is SDL set window icon. And this function doesn't want a texture, hardware accelerated texture for the GPU. It just wants a software surface. So that is what this is. This is the icon is going to be loaded as a software surface. And we need a pointer to the window to set the icon. So there are two different types of images in SDL. There are surfaces that are just in RAM, the image is just in RAM. And then there are ones set up to be used on the GPU to be accelerated. Those are called textures. So in this instance, I just need a surface because that's what it's asking for. So icon is a pointer to a surface kind of deal. And we've already got this window as a pointer to a SDL window. We already have this guy. We need to get this guy. So to do that, we need image load. This is going to allow us to load a PNG file. This is a string that is the image that we want to load. And it's going to load that image. It's going to return a pointer to a surface. If this fails, it's going to return null. So we're going to check if it's a null pointer that has been returned. And since I'm not holding on to this, I'm just going to do this on I'm going to create the pointer on the stack in this function call, and then it's going to go out of scope. And I'm going to clean it up first before it goes out of scope, but I'm not holding it in game because I don't need it for anything else. So I'm going to do this in init down here. And so basically I need to load this image, and it's not part of game. So I'm going to put it, I'm just going to create it directly on the stack here. So it's going to be SDL. It's of type SDL surface. A pointer to a surface rather. And I'm just going to say icon surf. So it's this is going to be the icon surface. And here's our function, image load. And what this needs a string that is where the image is. So the image right now is in the images directory, and it's called icon.png. So I'm going to put the relative path since the binary is right here. It can see, it's in the same level as the images folder. So I'm going to put the relative path in. So it's images icon.png. So now all we need to do is check to see if icon surf is a valid pointer, because if this fails, it returns a null pointer. Okay, so right here, just going to take this again. And this up here needs to be icon surf. And we can say error loading surface. And this one, I can, like I said, this should work. This SDL get error should work, but I'm going to change it to image. And so this is, we've created this surface on, it's on the heap, but the actual pointer is local to this function call right here. And we're checking it. We do need to clean it up, but we're going to use it first. So now that we have it loaded, we want to SDL set window icon. So basically we need a pointer to a surface and a pointer to a window. Now we have both of those. So this returns void, so we don't need to check if this failed or not. It is called set window icon. And so I believe we need, this is weird. It's not telling me what I need, but I think I need a window and a surface. That should be the order. Yeah. So this is G window, and then it's going to be icon surf. Oh, okay. That's why I spelled it wrong. Okay. Now, right here, if this fails, this is null. There was no memory allocated, right? And this is going to exit out. If it has not failed, then this pointer is something and there's something on the heap. So this is going to get passed and we're here. This can't fail. So if our pointer is good, our memory has been allocated. This is not going to fail. So after this, our pointer is still good. Our memory is still allocated. So we're going to use this SDL free surface right here. This is the way we free surfaces. We put a surface in and it frees it and there is no return. Okay. And it does say on this one too, it's safe to pass null pointer. But again, well, it's not going to be null pointer. It would exit it out if it is. So there'll be no way it'll ever be null pointer at this point. So this is going to be SDL free surface. And this is going to be the icon surf. Okay. And that doesn't it doesn't fail or anything either. But now this icon surf is immediately going out of scope, but just for good coding practices, I'm going to say, because I could always add in code after this and who knows what happens. I'm just going to set this to null. Just to, for good practice, because I could add other code in later on and completely forgot. And then this is still in scope and it's been freed, but the pointer still points to an address. And then what happens if I were to build, oh, that icon thing, I can use it for something else now. I'll set it to, and it's going to be a dangling pointer at that point. So even though I am going directly out of scope right away, since I did free it here, I'm going to set it to null right here. So now we should have an icon. So let's see if this worked. And we see that we do have an icon right here. And down here, we have this icon as well, right here. Okay, so let's it's easy to force an error right here with this image if we spell it wrong. And we can see what these error messages look like. Okay, right here, this is the error message that I created. This is what I wrote right here. Loading, error loading surface, period. And then there's this string on this image get error. And this is the error that SDL has given me. And it's pretty helpful because I can see right away that I've spelled it wrong. So let's see what happens if we change this to SDL. Let's see if this still works. Okay. And it did the exact same thing. So you don't need to use the image one, but I'm just doing it because it says that it's there. So, and you can kind of see, so these other errors, if I were to fake an error here, we wouldn't get a good message out of it because, if I were to just change this right here, we would get my error message, but we wouldn't get a real SDL error because no actual error occurred. I'm just faking an error. So here we can see an actual error in action. And when hold on one second. Yeah. Okay. So it looks like I didn't put a new line character, but we do see that even though this error occurred, that our cleanup function ran. But it looks like I didn't put a new line character on it, and I'll do that now. The all clean, yeah. Let's force that error again then. One more time. Okay. So now we see all clean is on its own line and good. Okay, so that was like 3 kind of mini things happening here. So the first thing we have is just we've restructured it and given ourselves a game, an event checking and a game loop. So the event checking, we've added it to game. We've added this bool is running, and we've added an SDL event to our game struct. And then in the game, since we have this game struct, we created a function, and I've just forward declared these in the C file because I'm not using them externally at all, so they're not in the header. They're just forward declared here, so the compilers are happy. But so right here, I'm using this SDL pull event. I'm populating the event, and this while loop happens as long as there is an event to populate. It's happening. And then we're switching on the type of it. If it's a quit type, we already know we can just set running. We can break out of here. And it's going to keep running through all the events, and then it's going to return from this, which is this game loop here. It's done this event. It's going to draw it one more time. It's going to wait 60 milliseconds. It's going to come up here and say, oh, this is false. It's going to return out of here, back into main. Main's going to say, I'm all done now. Cleanup happy. And the program exits. If we don't want to use the quitting, closing with the X, we can check key down events. If we do that, we need to drill down into the struct. The key struct holds a member of the key, or the event has a member called key, and it has a member called key sim, and that has a member called scan code, and that's the one that we want to switch on. We can check to see if the escapes key was pressed, and we can do the same thing, change the is running bool to false, which the same thing happens. Okay, we're not checking any errors here. We just broke out the clearing of the render and the presenting in the render in its own draw. And then we've created this game loop where it's just on this sentinel value, this Boolean is running, and it just keeps running in a circle as long as this Boolean is true, which it only gets set false 2 places up here. So if it is true, it's checking events, it's drawing, and it's delaying 16 milliseconds, and it goes back up again. And the event of the queue of events, it was cleared last one. So now we're only checking what's happened since the last time we finished checking the queues, whatever's new in the queue. All the other stuff was removed. Okay, so we have this game loop. So that's kind of how our game loop's going to work. We'll have update stuff in here as well, but we don't have it yet. I did put the new line character here. So now we have this. We're bringing the image module online. And we have to do it a funny way. We put in the flags we want. It returns some flags. We mask out the flag it returned with only what we want. So we get the answer of only what we want. And then we see, is that it? If it's not equal to what we originally wanted, an error has occurred. So it's a bit long. I know this is a bit complicated, but this is just the way it is. And us putting the flags into its own pound define helps that. So we're bringing it online here. And then in game free, we're taking it offline, and it's last in, first out. So it's coming out first, and then SDL quit. Oh, I just wanted to touch on here real quick that we did add this one right here for image init PNG, and you could use bitwise ORs and add JPEG and other types of images here, whatever it supports. So the reason why we brought the image online was because we want to load an image, and that's what we're doing here. And we're just doing it directly here. We're not storing it. So we're loading this from images, the icon image. It's being loaded as a surface. That's why it's just image load. It's loaded as a surface right here. We're checking to make sure that surface is not null. If it is null, then something's gone wrong. If it's not null, then we can set our window icon with it. We need the pointer to the window and the pointer to the surface. Once we've finished that, we can free the surface, and we set the surface to null, so it's not a dangling pointer. And that's everything in this one. So that is, setting up a game loop, handling events by quit event or key presses, and being able to work with images now. We have the images module online, loading an image for the icon and setting it. So we have an icon, and that should be about it for this video. I hope you enjoyed that, or I hope you learned something, and I will see you in the next one.